Stay tuned if you like to be in my interactive platform of discussion. Then you can listen and have your blank sheet and papers, and you can take down some notes for all the relevant, topics that you'll be able to gain from me or whatever. Okay, you can do that, and after that, you can also share that to your friends, neighbors, or whatever, and then at least happy ang world. Okay, right? Okay, mga palangga. This is my second for this day because the other one is very lengthy, right? So I'm gonna read first the problem. Okay. Calculate the energy required to heat 24 grams of ice at negative 20 degrees Celsius to steam at 150 degrees Celsius. The heat of fusion of ice is 334 joules per gram, and the heat of vaporization of water is 40.7 kilojoules per mole. The specific capacity of ice and steam are 203 joules per gram degree Celsius and 201 joules per gram degree Celsius, respectively. Okay, so better write that in a sheet of paper. And then Van, I will erase this also because see, this limited space for the solution for me. I don't love this. Gamay naman kayo space for my solution problem. Thank you so much, Ma'am Elaine Mendola Zayago, for passing my live reading. Okay. Hello, guys. Oh my gosh. So it's gonna be like that. So a while ago, I discussed to you already that the pre-discussion for this because it takes a longer time for me to discuss and then do it in a separate vlog, right? Then we'll go directly to the 5 different processes involved. And we need to be particular for the phase changes, temperature changes, like that. Okay, so I need to discuss a little bit only a theory that if you talk about phase changes, okay, like that, you need to use the formula of heat of vaporization, heat of fusion, heat of sublimation, like that. So your Q now here will be like this: Q N H delta V, okay, N delta HF, delta HS. So the phase you try to encounter. For example, vaporization delta HV. V stands for vaporization. So if that is also sublimation, then delta HS times the mass. Now if the value of your delta H, or let's say like enthalpy, for that, and that's also enthalpy change of your reaction, or enthalpy heat content, something like that. Okay? So expressed in either kilojoules per gram or kilojoules per mole. So that's why this formula could be adjusted to Q is equals to N times delta HV if your unit given is kilojoules per mole for your latent heat of vaporization, latent heat of fusion. But most of the times it's always kilojoules per gram, so that's why N. So the formula will matter. But if you do the conversion, you can do also, but this is the really the part that you should know. Okay, so this is for the phase change. For the temperature change, okay, use the Q is equals to MCP dt or CS delta T. Okay, like that. So there's a little bit of difference for that. Okay. So all of your organic liquids have its own heat of vaporization, heat of condensation, heat of sublimation values. So it depends on the problem what they are asking for, something like that. Okay. So sometimes we'll say calculate the energy required to heat isopropyl alcohol at negative. Ganun. Ilisda na yun ba? Calculate the energy required to heat chloroform like this, blah 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 blah, and so. So take note also the heat of vaporization of chloroform, alcohol, because this is only for water. Okay? But to some questions, as far as I could remember, they will not put everything the values. You don't want to find the values in the books, in the table, in the different appendix like that. Maybe they are very lazy to write in the question, but some also have for the purpose of discussion. But as far as I can remember, in the actual, because we are allowed to bring our chemical engineer's handbook, I don't know with other engineering courses, when we will be able to take our board examination, we will allowed to bring our handbook. Okay, so it's in there everything. Okay, like that. Okay, so the only difference is that it will take time for us to scan so many things. That's why we need to, prepare to study, everything regarding our curriculum, something like that. Okay, and it's inside the handbook also is very complicated to analyze because so many empirical formulas, variables like that, and you can so many writings, and you don't know where exactly you will be able to get the correct answer. It will take time. Maybe it will consume your whole hour, then you will get only low scores. Something like that. Be sure that you label already the particular, appendixes you want. For example, table of the physical and chemical properties of inorganic liquids and organic liquids. Ganon. Ito mga density, temperature, pressure, boiling point, melting point, viscosity, like that, specific capacity, whatever. Okay, like that. So, just label na. You have an index, something chuba-chuchu. Before I do the putting of the yellow color, the orange color, the red color, and if that talks about something like that, especially heat exchanger, like that, computation, the designing of a heat exchanger, designing of a heat evaporator, related problems, then I can easily go there. Something like that, okay? So, para-paraan siya so that you can really travel, extract where to go. Okay, something like that. But it's not also the guarantee that if you bring the handbook you can answer everything there. It's not. Because there's only a few also will come up inside there in the handbook. To the point? Mag-share tayo. Okay. Na atong mga buhaton ani sa naka-draw ani gamay kay akong whiteboard. Kasi ako sa chart. Okay. Para malapong kita. Nakaloka. Diba? Okay, so di ba kahinihintay guys? Let's start with the first. We are going to heat the 24 grams of ice to negative 20 degrees Celsius. So, step 1. I don't have to illustrate the graph. I discussed that a while ago, right? So 1, okay. It's gonna be, temperature changes first, Q, M, CP, DT, or C lang siya, delta T is equals to, so, step 1, first process, okay? So, it's gonna be, temperature changes time. So, mass, 24 grams. Okay. Specific heat capacity of ice, because this is 24 grams starting from solid. Heat capacity of ice, wait for a while. Okay, 203 joules per gram degree Celsius. And then let the change of temperature from 0 to negative 20. Because 0 is the freezing point of water. Okay, it's gonna be sa final temperature, 20, negative 20, diba? Negative 20 degrees Celsius. Okay? And then, initial will be 0 degrees Celsius. Okay, this is our Q. How much for this? Okay, ganon. Calculator, please. So, mga palangga. Hello, thank you so much for watching. Ma'am George, Ma'am Pelago, classmate. Okay, like that. So we have 20, nakakaloka, 20 times 203 times 24, we have 97,440. Again, kitaas naman siya. 24 times 203. Okay. Times 20 is equals to 97,440, mga palangga, no? Cancel grams, cancel Celsius. Left is joules. 97,440. 97,440 joules. Oh, this is our first process. And then for the phase change, we have, okay, Q is equals to the mass times the delta heat of fusion. Because it's still solid naman siya, and then you heat that to negative 20, so fusion. So heat capacity of ice, okay, and the heat of fusion of ice is 334. So, so mass of ice is 24 grams times the heat of fusion of ice is 334 joules per gram. Cancel the grams so the joules. So our heat of fusion is in process 1, 24 times 334, like that. So 8,016 joules. O, ano siya itong process 2. Phase change 1, 2. Or let's say Q1, Q2. Now let's compute for the Q3. Okay. Ang inibig sabihin, ang Q1 is 97,440 joules. Ang atong Q2 is equals to 8,016 joules. And now we go to Q3. What is our Q3? Okay, upon heating that one. Okay, our Q3, okay, this is temperature changes. So Q3. So our Q3 now from negative 20 degrees Celsius to 100 degrees Celsius. So it will be now turning into the boiling point of water. Okay? Like that. So Q3 is equals to the mass of the water, still 24 grams originally, right? Specific capacity of the, since that is nahimo siyang liquid, okay, since it is already liquid, guys, when you heat that from negative 20 to 0, so himo siyang liquid, so our specific capacity used here is for the water. You got the point? Is for the water na siya. Okay? Water. So 24 grams times 4.184 joules gram degree Celsius for water, right? Okay, ano naman siya? Liquid naman siya na phase. Okay, so ang temperature na ito yung na is we use the from 100 degrees Celsius to 0. So 100 degrees Celsius, boiling point, minus 0 degrees Celsius. So pila siya. Okay, water naman siya garaan. Okay, so 24 times 4.184, okay, times 100, okay, is equals to 10,041.6. 10,041.6. So 10,041.6. Cancel gram, Celsius. Review. Second time we review, guys, ha? To make sure. Okay, 24 times 4.184 times 100. Yeah, 10,041.6. Q3, 10,141.6 joules. Now for Q4, this is phase change na siya from liquid to gas, evaporation and vaporization. So we need to use the M times delta H of vaporization. So is the vaporization given? Yes, and the heat of vaporization of H2 is 40.7. Now this is 40.7 kilojoules per mole. So we need to convert this first, that there will be a mass. So we will change the formula into N delta H. This is number of moles, right? Okay. Now we have the 40.7. So we need to say this is a molar heat of vaporization. So 40.7 kilojoules over mole. So that we can cancel it. Let's have this mole instead of mass. Then, since we have the mass of 24 grams, then get the moles out of it by using the molar mass. So we have number of moles, so molar mass is equals to the mass over the number of moles. So therefore, we conclude that the number of moles is equals to the mass divided by the molar mass. So we have the mass of 24 grams and then the molecular weight or the molar mass of simply water, right? 18.016 by memorization. 18.6 grams per mole. Okay? Like that. Okay? Solve the moles first and multiply. Okay? So 24 divided by 18.016 is equals to, okay, times 40.7 is equals to, okay, equal to 54.21. But this is kilojoules. Take mga talangga. 54.21 joule, kilojoules. So let's convert this first to joules to match with our Q1 and Q2 and Q3. So convert how many joules in kilojoules? So simply times move 3 zeros. So 1, 2, 3. So it will become 54,210 joules. Because that is still kilojoules, right? Like that. And now we go to that is our Q3, our Q4, and our Q5. So what is our Q5? Okay. Our Q5 will be the temperature changes. Okay. Q5 temperature changes. Okay. So it's very clear, guys, that during heating, you will use the Q is equals to immersibility. And during change the phase, we need to use the vaporization, latent diffusion, latent vaporization, latent diffusion, gagano siya. In which, natin sa formula na siya. Okay, then we have Q5, the last process, turning into steam, right? Then we're going to rise to steam to 250 degrees Celsius. So our PF, klaro tayo na 250. And our initial temperature, that is 100 degrees Celsius. The initial temperature when the liquid water boils. Okay, so this is Q5 is equal to the mass of 24 grams, specific capacity of, take note, the steam. Because it's already now in a steam form. Be careful, when you substitute specific capacity, be sure that that is also the specific capacity of you are trying to solve. If water, water, ice, ice, steam, steam. Because normally this is the mistake also. There's also, including me before, I always use the water. Okay? Since I know that they have the same characteristic as water. But di pala siya. You will use the phase talaga na specific heat. Okay? Like that. So for steam or specific, labi na guys, especially if the problem don't put the individual specific capacity of ice, the steam, we will normally tempt to use the specific capacity of water again. Okay? Like that. So this, I think this is the most common mistakes generally. Okay, specific capacity of steam is ilan siya. So steam, specific capacity of steam na siya ay 201 joules gram Celsius. Okay. And then temperature 250 minus 1 degrees Celsius. Q5. Ganon. So, ada yun. So, 250 minus 100 equals to times the specific capacity of the steam, 201 times 24. 723,600. 73,000. So, 723,600 joules. So Q5. So now, question, calculate the energy required. So this is the total heat of the process from Q1 to Q5. Take note also that the problem is very confusing. It states only calculate the energy required. It doesn't state calculate the total energy of the process. So these things also make a little bit of confusion for the students and the examiners. Okay, so it implies only one. Okay, if you try to be strict with English grammar, it means only one energy to be computed, right? Or else it will change to calculate the energies required. So if we can compute all energies, 1, 2, 3, 4, 5, and then sum it up. But here, calculate the energy. What you should give ang total energy. Okay? And at the same time, take note, it's the word heat is not put also. Calculate the heat energy. But it's acceptable because later on it said required to heat. So obviously, heat energy, there's no question about that. Okay? But it has also a little bit of confusion to the type of problem. Normally, when you take this in a first look, something like that. So meaning this is the total heat energy of the entire processes involved in the phase changes during heating. Okay, i-add na natin ng mga palangga. Okay, 97,440 plus 8,016 plus 10,004. Okay, 97,440 plus 8,016 plus 10,041.6 plus 54,210 plus 723,600. Okay, so we have 893,000 total energy. 893,000 ano ba yan? 307.6 joules. Now, if the question says kilojoules, you convert very easy. 893.30 kilojoules. And then if the question also says how calorie, then you have to convert that to calorie. So, 1 calorie is equal to 4.184 joules. So, now mo times 4.184 joules, 1 calorie. So, you can compute for the calorie. And if say also what is the energy in watts, then you have also to solve this in watts. Watts is equals to joules per second. And you have already the calorie. And your problem only is second. So where can I compute in the second? So just leave that as it was. Don't touch. Because that is for watts. Unless it will also give the time. For example, calculate the energy required to make and the time it consumed is for 2 hours for the entire process. So that ma-meet na yun na to ang conversion sa watts. Kailangan mo seconds ang watts, joules per second. Okay? So, normally, we don't add that question here. But if we insist, we will add a following supporting statement at 2 hours of the entire process. So, I will say, calculate the total energy in watts at 2 hours over our time. Ganon. Because the watts involves time in the denominator. So how can we compute if there's no basis for the time involved? There's no time here involved during the heating process. If we add question like that, only wild imagination, things like that, so that we can maximize what are the possibilities to be asked, something like that. Okay? Ganon. Now, I notice also here, guys, I found it inconsistency also. But anyhow, this is a proper way how to solve. I just observed inconsistency. This is the reference I take in the, what do you call this one? University of Cambridge. Okay? Like that. So, see? 200 joules gram per degree Celsius for the ice. And 201 joules gram degree Celsius. Now, we have ako rin nabantayan ha. Okay. And then sa water, we have specific capacity of 4.184 joules per gram degree. And this 4.84 is very far from 200 and 203. Why? Supposedly, this must be higher than the steam, right? The specific heat of water must be higher from the steam because steam is so vaporized state, like that, very light compared to the liquid. So why the specific heat of water is just very small? So it will goes back to maybe I failed to write the correct unit during I write, Or maybe this is only for hypothetical question, just to learn how to do it, something like that. You get the point? Not reality problem. Okay, because if you have hypothetical questions in the examination, it's not necessarily true to the actual scene or in the reality, just only for the purpose of how to solve it correctly. So it could be also logical. But if you try to dig it out, it looks like they're given the wrong specific capacity of ice and the steam because 200 plus 200 plus chuba chucho, whereas the specific capacity of water is only 4.184 joules per meter Celsius. Okay, it looks like very far. Maybe this is hypothetical question only, okay? Like that. Or maybe I was wrong in putting the correct, steam specific to the steam stickers. But anyhow, it is being solved correctly. It doesn't matter. Okay, like that. The important is how you solve it correctly, not really the figure, the data like that. Okay, unless this is an actual examination that you have to be precise in the correct answer. Of course, you cannot do it, then you don't have scores. But this is only for the purpose of discussion. As long as you how to solve it correctly and properly, appropriately, not necessarily that the data will be exact or whatever. Okay, you get the point. Let's be clear. Maybe mo supak mo na ako masayot ako mas what I'm just explaining now. Okay? Because if I have to trace, I cannot find where is that my source. It's there in the University of Cambridge. Okay? Thank you so much mga palangga. Okay. Muna to siya. Natuon siya ang paagi niya guys ha. Okay. So Q1, Q2, Q3, Q4, Q5. So ipasok na sa itong brain cells. Kung magsugod to siya solid hangtod sa steam, kung di man siya pa-process, ganon. So that in the future examinations, yan na naging buhaton per week. Mora man na siya. There's no other thing. If you have to heat the solid going to steam, even though it is still other chemical, it's still the same process. So better ipasok lang sa brain cells. Okay? Para way lubog. Okay. Ganun na ba? Para why ikyas ang question mo kung watching makanan. Charot! Okay, di ba? Ang kaloka. Thank you so much guys for watching and listening to my vlog. If you're not subscribed to the channel, then you can subscribe it now. You click the notification bell for some news updates so that you see your channel guys. Bye bye. God bless everybody. O, di ba? Nakakaloka.